All right, so in the lab, we have to create two different plots. One is a position in the X versus position in the Y. Now, to do this, we're going to have to format our equation in such a way that we'll be able to input it into Google Sheets or Excel or whatever you happen to use to plot with. So let's look at what the actual two functions are that we're looking at. So for X, we have X final equals X initial plus V initial X T. And kind of in the Y, we have Y final equals Y initial plus V initial Y T plus 1/2 AY T squared. Okay? So we're going to have to plug different values in to these two equations to produce the different X finals that we're at different points in time. So we can assume that X initial is equal to 0 meters. We can also assume that our V initial X was what we found for rolling across the table during step 12. So step 12, velocity. Okay. Now in the Y direction, we're going to be able to assume that the Y initial is the height of the table. Okay, which you probably measured somewhere back in step 1. Our V initial Y is going to be 0 meters per second. And our AY is going to be gravity, which is negative 9.8 meters per second squared. So now XF is going to change, T is going to change based on the different values we put in. So we're basically going to be generating different values of time to plug in to find the different values of X that we want. So just again, making up some values, right now our equation should look something like this, that XF should equal, well, if X initial 0, we forget about that. Let me just assume that I'm going to make a fake value of, say, 0.25 times T, okay? And in this case here, Y final, let's say that I measured my table to be much higher than yours. Let's say that my table is 0.50 meters. I'm going to start, again, much higher. V initial Y times T would go to 0, plus 1/2 times AY negative 9.8 would be minus 4.9 T squared, okay? And again, this is coming from 0.5 times negative 9.8, okay? That's where that's coming from. So I would need to be able to format that in such a way that I'll be able to put it into the actual calculator, or the equation, I should say, of the Google Sheets. So when I type it in, it's going to end up looking like something like this, like 0.25 times, I'll be clicking on an A column where I'm going to generate my times, like an A1 will say, where this is, again, one of the columns of data. And then this will end up looking like this, equals 0.5 minus 4.9 times, again, it'll be that A1, that time, caret 2, to let me know that I've squared it. And again, that's coming from one of the data columns. Okay? So we're going to go in and actually do this now. All right, so now let's actually try to get plotting with these. So first thing I'm going to do is I'm actually going to make sure that I've got a little bit bigger of columns here so you can read a little easier as I'm typing in. And I'm just going to make these a little wider just so you can see them. So the first thing we need to do is generate our time values. Okay. Now, when we're going to be putting our times in, we want to start at time equals 0, and we want to increase by 0.01 increments. All right. So now I'm going to drag down all my times from the 0 till when I think I'm going to hit the ground. All right. So based on those numbers I created, I figured out that I should take till about 0.55 seconds till I hit the ground. Okay. So I drag it all the way down. Oop, what happened here? Oh, it went over. So I drag it all the way down till I'm about 0.55 seconds. And I've got my times. Now, the first thing I need to do is I need to put my X positions in. So this is my X position. Okay. And then my other column is going to be my Y position. Okay. And if you remember, we just talked about the fact that the equations are going to equal 0.25 for the X times, and I click here, and it ends up being A2, not A1, for the Y position. So again, it's a little hard to see when I first do it here, but it reads right now as equals my velocity. I generated a value of 0.25. Again, yours will probably be different, times the A2 value, and I hit enter. So I'd assume that yes, my position at time equals 0 should be 0. I'm going to grab that and drag it down, and drag it all the way down till I get to the end. And I've got all my different X positions. So it looks like I should go over about 0.1375 meters. So now as for the Y, my function says that I should be starting at 1.5 meters. So again, I just put equals 1.5. But it was minus half of negative 9.8. So, or plus half of 9.8, or negative 9.8, which gave us negative 4.9. Okay, times the time. So I click on the time column there, squared, so caret 2. And the caret is above the 6 on the regular keyboard. Enter. So it makes sense that my initial Y position is 1.5. So again, I click and I drag it down, and it looks like, again, at 0.55, I almost get all the way to the end. So I'm actually going to drag one more block here past to the 0.56, drag each of these down, and if you notice, when I get past the 0.56, I now get to a negative value, just so you can see that clearly at 0.55 seconds, I would hit somewhere in that 0 range. So I've got my X and my Y values that I want to plot as a scatter plot. So I'm going to select the B, hold down the Command key or the Control key on a PC, select the Y, and I'm going to do Insert, Chart. And it's going to take it a second here. And initially it picks a line chart. I don't want a line chart. I want a scatter. So I scroll down, I find my scatter, and it makes that nice, happy scatter. And now we're going to customize it a bit. Okay. So we've already got the chart style kind of okay. Axes and titles. So the title should be, basically X and Y position, we would say, of a projectile. Right? Which seems like a projectile. Gotta spell it right. Then I'm going to do a subtitle, which again always should be your name. So in my case, it'll be Mr. Magno. And then I got to label my axes. So the horizontal axes, in this case the x-axis, should be displacement in the x direction. And you say in meters. Okay. And I'm going to actually just copy that. And vertical should be very similar. It's just now, it's not the x direction, it's the y direction. again, in meters. Okay, so I got those two on there. Series. I am going to make it a little bit smaller so it's easy to see the dots, make them down to 2s. Since it's calculated data, I really don't have error bars, but I still do want to add a trend line to it. It's not linear. It is going to be a polynomial trend line. Okay, and I want to label it with the actual equation so that I can see it. Okay, and I will show the R value, but R value is 1's fine. And legend. I don't like my legend at the right. I generally like them at the bottom. Okay, and so for the horizontal axes right now, it looks to be okay, but if I get down here to my vertical axes, I might not want to go below 0. So I'm going to set my minimum to 0, just so that I don't have to see below that 0, but I might give the maximum a little higher to like a 1.6, just so I can see the whole, it starts and then kind of curves down. Okay. Grid lines look okay for it, so I might just say that I'm done with that. Just give it the little close. Oops, sorry, here. Trying to move this out of the way so I can close it. And there's my XY position graph. And again, if I want to copy it somewhere, I can just do copy chart, put it wherever I happen to need it.